Hello everyone. So in the last video we started setting up our GD extension using C++, and just a reminder, we're doing that because it gives us access to a lot of cool C++ libraries like this LZ4 compression library. You can see we set that up here in the sconstruct file. So we have our base world generator class and its header file here. Before we start setting up our actual world generator C++ class, we're going to go ahead and set up everything in Godot. So I'm going to open up the project I made when I tested the GD extension. Alright, so here we are in Godot. I'm just going to start out by making a game world scene. This is just going to be our main game world. Okay, and now I'm just going to make a player scene. And for the player scene, we're just going to make a character body. Make it the scene root. Rename it to player. I'm just going to add a collision shape 3D. Make it a capsule shape. Bring it above the floor. Alright, and then what we're going to do is add a 3D node to act as the pivot point for the camera. And then I'll just make it the camera a child of that. So now I'll just attach a script to the player node. And I'm just going to paste this pre-made player controller script that I made earlier. Basically the same as the original, but with mouse and camera control. And then we can also choose to fly or sprint, which just means fly faster. This script will be made available as well with the entire project. So now in our game world, just drag my player in. So now I'm just going to make a new script down here, and we're going to call it world config. So delete this, do class name, world config. We'll make a bunch of export variables for all our world configuration options, and then later we'll configure our GD extension to load these variables when it generates the world. So we'll add an export category, do world settings, so first we have this world scalar integer. And this is just so that when we are deciding on the final size of our world, we can just take the size of our clip map, which is 1664, and then multiply it by this world scalar so that our clip map always matches up to the chunk separations. Okay, then we have our world Y minimum and Y maximum, and I'll work on renaming these better because right now I'm only using these to generate the land masses like the continents and islands, but once I add mountain ranges, our world's highest point climbs well above our world Y maximum we set here. So it's not really the world's Y maximum. You'll see what I mean later. Then we of course have our sea level, so that we can set it at any point we wanted to for any reason. So here we have our max initial chunk distance. So when we initially generate our world, I don't want to have to generate every single chunk in the entire gigantic world before we are allowed to play the game. So instead we choose a distance around the player's starting position to generate initially before the game starts. And then if the player wanders beyond this area, we will generate those chunks on the fly. So next I'm going to add a new export category called chunk settings. Set our chunk size to 256. So one chunk is 256 meters wide. And then here we have our cache padding chunks. So basically the chunk cache needs to have all the chunks for the Clipmap area loaded so it can display the height data. But we also want to have a little bit of a buffer around the player so that when the Clipmap snaps to a new location, we don't have to wait for chunks to be generated and or loaded into the cache. So since we use multi-threading later on to load these buffer chunks into the cache, the larger you make this number, the longer you're going to be loading background chunks during your game. And then next we have our height data resolution. So I put this right here so it would make more sense to you. If we had it set to 1, we are going to generate height data for every 1 meter. Since I have it set to 2, every 2 meters we will generate a height value. So basically the higher this number, the more efficient. So that's a pretty good start to our world configuration. Go ahead and save this. So now that we have our basic world config, I'm going to go to the game world node here, make a new script, and I'm going to call it world gen. This is our basic Godot facing world generation script. So this I'm going to make a tool script so that I can regenerate the terrain every time I click and export Boolean. First, we're going to want to reference our world config and generate a new instance of it, and it will load in with all those default values. I'm also going to make this export variable for regenerate terrain, so we can enable it whenever we want to regenerate it, and then it'll set itself back to false when the terrain is done generating, like this. So now we're going to want to make a reference to our clip map that we haven't added yet. So let's go ahead now and make this clip map scene so we can then add it to our game world. Here we'll do new scene, 3D scene, call it clip map. And I'll import my clip map mesh. And then if we instantiate that in our clip map scene, go to wireframe, we'll see that by default it generates LODs for the mesh. So double click the imported mesh to go to your advanced import settings and unclick generate LODs and then re-import. There we go. So there's our clip map. And I'm just going to make this clip map mesh local now so I can set it as the scene root. Get rid of that extra node. And now let's just add a basic clip map script to our clip map mesh. And we'll just make an export variable reference to our player, because we'll want the player position at all times. In our clipmap script, we're also going to want all our world configuration variables. So one way we could do it is this. but I don't think that's very clean because our world configuration is supposed to be a central source of truth for essential world configuration options. So I don't think it would be good to make a new instance of it in every script. But the reason this would work is because every time I make changes to my configuration when I'm testing, I just alter the script. So then every time this script runs, the changes get updated in all the necessary scripts. But just so we don't have to do this in every script that we want world configuration variables in, let's go ahead and take this out. And then also in here. And then go back to our world config file. We need to remove the class name because we are going to make this an auto load. And making it an auto load assigns it a class name. And we're also gonna make it into a tool file so that these are all accessible in the editor as well. And we'll go up to our project settings and go to globals, auto load, select our script, world config, and set it to be called world config. Add that. So now in all our files, all we have to do is call properties of our world config class. So now if we go to our game world scene and reload the scene, you can see it prints out our sea level. So that makes it so we can do things like generate the terrain on the fly in the actual editor, as well as the game itself. So now that we got our world configuration all set, we want to reference our actual Clipmap mesh, this thing that says main version. Do that like this with the get node. And then next we're gonna wanna take this world config chunk size, which you'll remember we set to 256, and that becomes our terrain snap factor, which is the furthest distance that the player can get from the center of the clip map before the clip map itself snaps to the player and then updates the terrain heights. And then also from our world config we'll get our height data resolution, which we had set to 2, which just means we will have a clip map vertex and a height value in our cache for every 2 meters. Okay, so now we want to get the fixed size of our clip map, which I know to be 1664 meters by 1664. So I could just hard code it in like this. And then we are also going to need access to, and then our Clipmap scene is also going to need access to our World Generator class, our actual GDExtension that we started to make. So back in the World Generator file, I'm just gonna instantiate our World Generator class like that. So now back in the Clipmap script, I can reference my World Generator script with getParent, and then we get our World Generator like that. However, this will only work in the editor if I make our Clipmap a tool file as well. Also, I'm just going to rename this to Clipmap so that our World Gen grabs the right node. In order to make it so the Clipmap snaps to the player's position, we need to be able to know its last snapped position, like this, and we set it to this vector3.infinity, and that's just so that it never becomes 0, which is where our player begins in the game world. Alright, and then next, because we are going to apply a Clipmap shader to our mesh here, we're going to want to have a material variable and an image texture variable for the height data. So now let's just add a shader to the Clipmap mesh. Go to Surface Material Override, Shader Material, boom, new shader, clipmap.GDshader, create. So we're just going down the tree of things we need to create as we need to create them. So let's go ahead and start the shader. Pretty simple. So below this, we're going to have two sampler 2Ds, one for height data and one for biome data. And we do repeat disable so they don't repeat past the world bounds. And then we have our world Y minimum and world Y maximum that we set in our world config. And I just set them to -100 and 100 for default values. But we're going to manually set these from the world config in our Clipmap script. And then for the actual height of our, and then in the vertex function here, we're really just simply setting the height to our height data sample. So we get our height sample with this texture function, and we just pull the red channel. And then we set the vertex Y position to our height. And then just so we can color the height from black to white, we can just take our height value in the fragment function, and then we'll just set the albedo to this height value. And the biome data here is just so that when we set up biomes and stuff, we can view it as colors on our clip map. So we'll save the shader, and we'll go back to the Clipmap script. And in the ready function down here, we will set our material to our surface override material. And then we're going to set up the Clipmap snapping here in the process function. First, we'll just take our player's global position, and then we basically get a position of the player that is snapped to our terrain snap factor using this snap function. This snap function returns the multiple of step, which is this value, which is closest to x, our input value. So for our case, as our player goes over the terrain snap factor in terms of distance from the center of the clip map, it snaps to the next step. So then that way, all we have to check is if our snapped position is not equal to our last snapped position, because if it's not, we want to snap it. So then if it is not, if this condition is true, we want to set our last snap position to our snap position. So on the next frame, this will be false. Update the global position of the clip map itself to our new snapped position. And then the most important part, we will finally call this update height texture function, which just means that when our clip map moves to a new location, the image that gets passed to our shader to drive the height of our terrain needs to be updated to reflect the new chunks in the new location. And we do that with our update height texture function. So below this, let's just define that function real quick. So now in our game world, if I go ahead and instantiate our clip map scene, and then assign the player in that Clipmap script. So now if I zoom out and move our player around, you can see every time we reach that terrain snap factor, the terrain snaps. So before I close out this video, I just wanted to give you a little sneak peek at the end result of this project. I'll have the full project available on GitHub once the rest of the tutorial series comes out. It's functional right now, it just needs to be cleaned up a little. Right here you can see my little character we got for scale, but if I zoom out from the ocean plane, you can see that the center of our world here is this giant pile of mountains. But if I take my player and drag it over here, so So over here, you see some more standard terrain. And for scale, that's the size of our little character. And the most important feature of this is that we have lake biomes, where we deform the mesh for the lake and actually generate a lake plane with the correct shape for the lake, with a little bit of added padding so that the water plane always extends into the terrain itself. You can see we have a chunks folder managed by our ChunkManager. So then now that we got our Clipmap scene and our game world scene set up, in the next video we'll finish our GDscript code so that we can jump right into the actual World Generator C++ class so we can generate terrain like this. So I'll see you in the next one. Thanks for watching.